If we want to store address of a website in Monet database, we can use URL data type. I will now create one table that will use URL data type. And then I will store one URL inside of this table. And we can see that we can store this URL as a string because URL data type is based on a string. But it is also possible to insert directly a URL data type like this one. This time we are using this prefix URL to transform this string into URL data type. And then we can read from our table and we will get this result. Now, if we want to transform some string into URL data type, we can use either convert function, we can also use cast function, and as we saw earlier, we can use URL prefix, and in all three cases we would get the same result. We would get the URL data type. I will now clear my screen. For working with URL data type in Monet database, we have many functions. And to show you those functions, I will first truncate my table. So I will delete everything from it. And then I will insert just one URL. And this is that URL. I will place it inside of our table. And if we jump here to this web page, we can see that that same URL can be broken into parts. And those parts are protocol, user, host, port number, path, query, and anchor or fragment. And I will now show you functions that can extract all of these elements from our URL. And those extracts will be always of a glob data type, but sometimes there will be nulls because sometimes that element will not be present inside of our URL. Let's now go back, and first we will extract our protocol or schema. So we use this function sysgetProtocol, and our protocol is HTTPS. Then we can extract user. We will use this function sysgetUser, and user is just me. Then we can get host. Host is www.monet.org. So this is our host. Then there is similar function to this one, and this function has second argument. This function name is URL extract host. Second argument could be false. If it is false, it will give us the same result, but if it is true, then it will remove www part. And I will now clean my screen. I will again paste our URL inside the terminal, but this time as a comment, so we can see always our URL, and then we will continue. We will now read our port number from our URL. Our port number is this one, so we are using function getPort. Then we can read the context or path, and that is location of our file, so it will be docabc.html. Then we can read the query. So this is how query looks like inside of our URL. And we can also read anchor or fragment, and for that we are using this function getAnchor. So that is this last part of URL example. I will now clean the screen. In our URL, we have a path docabc.html, and that is this part here. But we can read this part step by step. For example, first we can read just a file name, and that file name is abc.html. We are using this function getFile. Then we can read the file name without extension. For that, we have this function sysgetBaseName. We would get just ABC, and we can read just extension. And for that, we are using this function sysgetExtension. Then from the host, the host is this www.monet.org. We can read just that domain, and that domain is org. Then we have a function sys is a URL. This function will return true if this URL is of a correct type. and that is true. This is really a URL. And then we have a function that will return a location of a robots.txt file on our web server. Now, this file here is always placed inside of a root of our web server. So this function then can know what would be address of this file. And this file is used to give instructions to search engines like Google or Yahoo how to crawl our website. And I will now clean my screen. If we want to create a new URL, we have a function sys.newURL. This function can accept 3 arguments. And all of the arguments are strings. First one is our protocol. Second one is so-called authority. Authority is combining user, host, and port number. And we also have pet, and this would be the result. But this function can also work with 4 arguments. In that case, we have these arguments here. So we have a protocol, we have a host, we have a port number. This should be integer, and we have our pet, and we would get a similar result. I will now clean my screen. Now I will talk about the network data type. And when I say network data type, that is actually an IP address and IP address of IPv4 type. And first I will create one table that will use this data type. Then we can store one IP address inside of this table. And for that we can use a string because this data type is based on a string. But we can also insert a pure network address like this one. So this is that init data type. And as always, we can use convert function to transform string to this data type. We can use a cast function, or we can use init prefix. And in all 3 cases, we would get the same result. I will now clean my screen. In Monet database, we have operators that can be used to compare 2 IP addresses. We'll now go again to this web page. And here we can see that we can use all of these operators, smaller, smaller, equal, equal, and so on. So all of the mathematical operators that can be used to compare 2 numbers can be used to compare 2 IP addresses, because IP addresses are basically just big numbers. If we look at 2 IP addresses, the easy way to see which one is bigger is to think like in this way. We can pad this number with a 0, and then we can remove dots. So we would get 2 numbers, and by looking at those 2 numbers, we can see easily which one is bigger. So when we look at IP address presented like this, we should think about numbers like this one. So we can easily see just by looking which IP address is bigger, and that is the logic. For comparison, this logic will always work. And then we have a way in Monet to compare those IP addresses just by using these operators. So I will now go to terminal, and I will paste that statement, and we will see that this IP address on the left side is bigger than this IP address on the right side, just like this number is bigger than this other number. I will now clean the screen. Beside those comparison operators, we also have operators that will check whether one IP address belongs to some network. And to understand that, we will again go to this web page, and we will see that this is the biggest IP address that can exist. And each number, 255, can be presented as 2 on 8. So that means that the total IP address can be presented as this number 2 on 32. Now this is a real presentation of this number. This that I showed you earlier is just so you could eyeball which address is bigger. And I'm showing you this because I want to explain you how to differentiate between 2 parts of network address. Now let's now look at this table. Here we can see one IP address, but this IP address is divided so that this number is for network, and all of these 3 numbers are for computer. Such network address would be used for really big network that has a lot of computers, so we need 3 numbers to label them all. But if we have a small network like this one, in that case, we just need one number to mark all computers. So this network would have at most 255 computers. And here it is easy to make a distinction because one part of this IP address is red and the other part is black. But in the real world, we would use syntax like this one. And what does this mean? Well, remember that total IP address is 2 on 32. So that means that first three numbers, these three numbers, can be considered as 2 on 24 because 2 on 8 times 2 on 8 times 2 on 8 is 2 on 24. So we would use this syntax to say that first three numbers are for network and the last number is for our computer. Now that we know that we know a distinction between IP address of a computer and IP address of a network, and that we know for this syntax, we can now talk about these special operators. Here we have an example, and this example is using this operator, and this operator is checking whether this computer belongs to this network. We can obviously see that this is a network address because it only has three numbers, and there is similar operator like this one. It will work in the same way as this operator above, but with one distinction, and that is when we compare two network addresses, if they are the same, this operator will return true. Let us now see in terminal how these two operators work. So first we will check whether this computer belongs to this network, and the answer is true because three first numbers are the same. And we can also check whether these two networks are the same networks, and because all of the numbers are the same, obviously they are the same. And we can also use reverse operators, so they will just reverse a logic. So it is important always to be careful which IP address we place on the first position and which one is on the second position, because order is important. I will now clean the screen. Now we can talk about functions that can be used to work with IP addresses. First, we will have this function, and this function will just create a shorter version of a network address, so it will remove these zeros at the end. Then we have sysbroadcast function. This function will create so-called broadcast address, and this address is composed of a network address plus all other numbers will be 255. Such address is used to send a message to all of the computers on one network. Then we have a function that will just remove this subnet mask, and it will return its result as a clock. Then we have a function that is doing something that we already saw. So this function will check whether this IP address belongs to this network. And we already saw that we can do the same thing by using an operator. And there is then again similar function that will work in the same way, except if we compare two networks, then it will return true if those two networks are the same. And counterpart of those two functions are these functions, right shift. So we have right shift and we have right shift assign. They're doing the same thing, just the logic is reversed. So instead of placing IP address of a computer on the first place, we have to place it on the second place to get the true. So they are same functions, just everything is in reverse. I will now clear my screen. Next, we will talk about function sysmasklen. This function will return our subnet mask as a number, as an integer. Then we have function sysnetmask. This function will return our subnet mask, but instead of writing it like this, /24, it will be written like this. So this is the same thing, just a different syntax. Then we have function sysnetwork. This function will just return address of a network from address of one computer. So it will replace all other numbers with zeros, so that only numbers for a network remain. Then we have function sys set mask len. This function can change our subnet mask. So instead of having subnet mask 24, we will now have subnet mask 16. And we also have a function that will return our IP address as a text, and it will add, as we can see, a subnet mask. I will now clean my screen. And there is one more function. And with this function, I will show you that subnet mask doesn't have to be a number divisible with 8. It doesn't have to be just 8, 16, 24, and so on, but it can be any number. And this is the result that we would get. We go here again to our web page. We can see that this number is calculated in this way. We know that the whole IP address is 2 on 32. So when we divide that with 2 on 30, because our subnet mask is 30, so we are using 2 on 30 to designate our network, we are only left with 4 values for our computer. And those values are from 0 to 3, so we would have this number 3 at the end. It is similar if we have much easier situation when our subnet mask is 24. In that case, we know that first 3 numbers will be used for our network, so they are zeros, but the list number can be up to 255, so we can have up to 255 of computers in this network. And similar to that, we know that we can only have 3 computers in this network, and even when our subnet mask is 17, we can still do the calculation. 2 on 32 divided with 2 on 17 is equal to 2 on 15, which is 2 on 7 multiplied with 2 on 8, which can be presented like this. So we would get numbers 127 and 255. And if we multiply these two numbers, we would know how many computers can be on this network.